So let's start with the basic parts. The system consists of a dosimeter, which measures radiation every second, and then it sends that to a display unit, such as this one. The display unit, in turn, visualizes the measurements as colored bars symbolizing your dose rate, which means that when no radiation is on, these will be at 0, like now. When you press the pedal, it will go up, and when you release, it will go down again. So you will always have the possibility to see your personal exposure right now. RaySafe i3 comes in 2 different configurations. We have the standalone version, including this display unit. The system consists then of dosimeters and this unit. And the unit includes radio transceiver, data storage, and all the display functionality. Apart from that one, we also have the RaySafe i3 OSD system, which I have here on my left-hand side. It does pretty much the same thing, but instead of the standalone display, you would use any display that you might prefer, or video switch, for example. Technically, the system uses our hub. So this does all the radio communication, data storage, etc. Then the display would be any display that you might prefer or have access to. So that said, I would like to show you all how this all comes together. So in the room, we have this radioactive source. It's an americium-241 source. And for all the physicists in the room, this is primarily an alpha emitter. These don't pick up alpha, but it also emits a certain amount of gamma rays at 59.5 keV, which is very similar to the X-rays you would see in an interventional X-ray room. Okay, so let's try the inverse square law to start with. And by the way, you will see the measurements on this screen. So I hope that's all visible. So let's imagine I'm a nurse, for example, and right now I'm standing pretty close to the patient. And you can see on the screen that I'm getting a fairly high reading. And that reminds me that maybe there's a better place for me to stand. So I'll take a few steps back, and you can see immediately that the bar drops off. And here it's important to remember that this bar has a logarithmic scale. So what you just saw was the bar going down with about 50%, but in reality that means I reduced my dose rate by 90%. It went from approximately 2 millisieverts per hour to 0.2 millisieverts per hour. And that way, I've learned a better way to protect myself. I've learned that maybe that spot isn't the best way or the best place to be. I should rather stay over here, a bit further away from the radiation. Okay? And as a second example, I'm going to try shielding. Here's a thyroid color, normal one that you would have at the dentist or in the cath lab. It's got, I think, 0.25 or 0.5 millimeter lead. And let's imagine that this is one of the ceiling suspended shields in the interventional room. And let's say I'm the operator or the anesthesia nurse, for example. Someone who's close to the patient and should be using a shield. And right now, I forgot my shield. And again, you can see I'm at roughly 2 millisieverts per hour. And the i3 system reminds me that, hey, Fredrik, you should use the shield. Oops. So let's insert the shield in between. See what happens. It goes down to below 0.2. So I can see there's, I reduced my dose or my dose rate by roughly 90–95% by remembering the shield. And that way, again, I have avoided unnecessary radiation exposure. So let me cover this up again. And that's in the day-to-day use for the medical users. This is the main purpose of the system. It gives me the alarm effect or the reminder that, hey, Fredrik, remember what you learned at your radiation protection training? Remember the shield, remember to take a step back or stand by a colleague. And it also tells me that when I do those things, it actually works, or it doesn't. So I learn what way I should act and which tools I should use to keep my personal radiation exposure at a minimum. All right, and while we're at it, excuse me, I'd also like to mention a couple of details about usage. So this one goes outside the lead apron. I didn't wear one today because this radiation source is really weak. But if this is a lead apron, I would put it outside. I would put it facing the radiation. And if I'm right-handed, standing by the patient, I would normally be on the left side of my chest. And an important thing is to keep the front facing forward, because it doesn't pick up radiation very well from behind. When I'm done, I can clean it off. I can disinfect it. We have tested most common disinfectants on the market. You can't take it to go swimming, but you can clean it off with a damp cloth or any surface disinfectant. Now, when I'm done, I can look at the data, or my RSO or radiation safety responsible or medical physicist can look at the data. We can run studies. The data is stored both in the dosimeter and, in this case, in the hub. So let me show you exactly what's stored in the dosimeter. And then I will share my screen. Let's see. Okay, good. Sorry about that. Now I'm going to take my dosimeter and I'm going to plug it in into this micro USB connector. And I will be using a software called Dose Viewer, which is included with every i3 package. And it's a brilliant tool to check one or a few dosimeters at a time. And right now you can see the exposures that I just did. So let me zoom in. And here's the first one. You can see when I tested the inverse square law. So at first I'm really close, and then you can see I did something. I backed away from the radiation, and you can see on the orange graph how my dose rate has gone down second by second. The blue graph that grows shows my accumulated dose, and you can see that it grows slower and slower. And then I can have a look at when I tested the shielding. You can see I started out pretty high, and then I accidentally removed my dosimeter from the beam. Then I put it back in the beam, so it's high again. And then at the end, I inserted the shielding. That's right here. So you can see right in the data how my dose was reduced by using shielding. When I've done that, I can select a nice time interval like this. Then I can select dose table. And then I have the same thing, the raw data in table format. And I can export that to CSV, which is compatible with Microsoft Excel, for example. So I can use that. I can collect these files and run further analysis and make other types of charts in Excel. Share with my colleagues. I can use them to run studies. I can also use them to look back in time. Let's say I got a high reading on my legal dosimeter, my Landauer badge. Then I can check what happened in May, in the month of May. Then I can take my dosimeter, read out the data, and check if there's anything that stands out. What happened then? What date? What time? What happened? What procedure was I running, etc. Okay. Besides Dose Viewer, we also offer a sister software called Dose Manager. It's an optional software. It allows us to do the same things, but with multiple dosimeters at the same time. And then you wouldn't have to connect all the dosimeters by USB to Dose Manager. Then you would download the data from the hub directly to your PC. And then you can select multiple dosimeters, check all the graphs against each other, export all of it to Excel. With the i3 OSD system, I also have the opportunity to connect directly to the hub using a web interface and download the CSV data directly from the hub. That's really convenient. And that's it. So RaySafe i3, we have the dosimeters. Let's look at that one again. This is how it looks. Closer, all right, good. We have the standalone i3 with this everything in one unit. We have i3 OSD, which allows you to use any display or video switch that you might like. And that's the whole system. So thank you so much for joining this demo. Now I'd like to invite you all to type questions in the chat. Thank you.
Okay, thank you, Fredrik. We have a couple of questions. And the first is regarding the power source. Can you tell me or tell the attendees something about the power source?
Right. Naturally, we have a few units here that need power. Let's start with the dosimeter. The dosimeter uses a coin cell battery, CR2450. It lasts for roughly 1 to 2 years, and you get a warning a couple of months before it's out. When you run out of battery, you can unscrew the top 2 screws here and take off a little plate and just replace it yourself. This one runs on it's 12 volts, but you use a normal Walmart or power supply unit, 230 volts here in Europe. So wall power for that one. The hub uses power over Ethernet. So in the most common scenario, this hub would be mounted in the ceiling or high up on a wall. And to avoid running multiple cables up there, we opted for power over Ethernet. So you put the power unit at a convenient location, and then you run a 30-meter Ethernet cable to the hub, and that's included in the package. The system, the i3 OSD system, I should say, also includes a video unit, which is another tiny box which sits in the technical room, and that's where you connect the actual video cable, and that also runs on wall power.
Perfect. So, I mean, you have talked some about it, but exactly how many components does this system contain?
So if we start again with the standalone, then we have the display, of course, power cables, includes the rack. This is a storage rack that you would put on the wall. And then you would have dosimeters. The i3 OSD system, again, same dosimeters, same rack. You have the hub. And let's see if we can show these. We have the video unit and the power over Ethernet. So that's 3 units for the installation of the system, plus the dosimeters and the rack.
Perfect. Regarding the dosimeter, does it need to be calibrated or?
No. So it comes calibrated in our state-of-the-art labs here at RaySafe. And we have a specification, which you can find on the website. And based on statistical analysis and experiments and long periods of testing, we can say that during the lifetime of the dosimeter, it will stay within those specifications. So you don't have to send it in for calibration.
So how accurate are the dose measurements?
Again, the specifications are on our website, but we promise dose reproducibility of plus minus 10%. So that means if you expose it twice with the same dose, then both exposures would be within 10% deviation. excuse me, we also publish a 10% dose rate uncertainty within the common dose rate range. If you go outside that, the uncertainty becomes a bit bigger. So those are the main specifications. I can also add that the energy range that we have defined is based on the PTB N series or the ISO 4037 N series, going from 40 kilovolts to 150 kilovolts. And that means a mean energy of about 30 kilo electron volts up to 120 kilo electron volts.
Thank you. Is there any easy way to see the accumulated dose without connecting the dosimeter to the computer?
Depends on what system you have. With the standalone version, you can click an option to show an accumulated dose right on the front page. You can also reset it with a button there. With the OSD system, the easiest way would be to connect to the web interface and download the data.
And what type of detector is the i3 dosimeter?
The dosimeter uses solid state sensors, very similar to our X2 products, for example. So with a bit more detail, it uses a number of silicon photodiodes with varying filtration, and then it runs calculations on those varying signals to calculate the energy and the dose rate.
Thank you so much for this answer, Fredrik. I think we're running out of questions, to be honest. I think we have answered most of them.
Very nice. Thank you so much for the questions. Thanks for joining.
I think there's actually a couple more questions in here. They seem to be rolling in a little bit. Is there any advice on installation and first-time usage?
That's a big topic. So for the standalone version, if we start with that one again, it has VISA 75 bolts on the back side of it. So you can either put it on the wall like any smaller TV, for example. We also offer a few different mounting solutions for different scenarios. For the i3 OSD system, you have to place a few units and run a few cables. The hub goes in the ceiling in the lab. The other units normally go in the technical room. And there are possibilities to connect the video unit to your main monitor that comes with the X-ray system, depending on which brand you have on the X-ray system.
And then we have a question about how accurate are the dose measurements?
I think we
cover that one.
It's about that one. But if there are any more specific follow-up questions, I'd be happy to answer those.
We just received a question about if i3 is suitable for the C-arm system.
Yes, absolutely. If we're talking about surgery and mobile C-arms, then you would probably mount the system in the room and not necessarily on the C-arm. So it sort of depends on the context. We made it primarily for the interventional X-ray field, but the radiation would be the same for surgery. It's just that if you have a C-arm that moves around, then it might be a little bit tricky to also move your screen around. But if you have a C-arm that lives in one operating room, then you could just mount, for example, this one anywhere.
Is there a limited number of dosimeters that can be connected to the system?
Yes, good question. Both systems, the standalone and the OSD version, they can both connect 8 dosimeters at any one time. That's the number that we can show on the screen. You could have any amount of dosimeters in your possession, but only the 8 first that connect will be on the screen.
Can you tell anything about radio interference or regarding that?
Yeah. So all our i3 products are they're tested and certified against radio standards in all the countries and regions where it's sold. The requirements differ a little bit between regions, so we have different versions for example, Europe, North America, parts of Asia, excuse me, to comply with the local regulations. But if you use the correct version, and in our official channels, you would only be able to buy the correct version, so that's no worry. Then it will be compatible with any other equipment you might have in the room. It's not sensitive to interference from other products, i.e. other products disturbing the system. We did have a prior version of the system earlier on, which was somewhat sensitive to cell phones, for example. That's not an issue with the i3.
Can you tell us something about the range between the dosimetry and the standalone or the hub?
So the radio range, yes. Theoretically, the range would be somewhere between 20-30 meters if I'm in an empty parking lot, for example. In practice, you would be in a room with usually fairly thick walls with LED. You might have firewalls, electrical cables, and whatnot. So usually the range will be more or less limited to the room. You might be connected just outside the room or in the control room, for example. But in most cases, you would, without problem, cover the whole room and not have an interference with the next room.
Perfect. Is it possible to see the accumulated dose on the OSD version?
Not on the display. There are several reasons behind that, but no. You can configure it to show the average dose rates of the last 7 exposures. Then you would use a reference dosimeter, which is placed in the room, normally on the C-arm. I don't have a reference dosimeter here, so it's not shown, but otherwise that would give you a way to see how you did in the last exposures if you weren't able to look at the bars while irradiating.
Is it sensitive to sunlight in any way?
Not that we have ever encountered. We have tested it with pretty strong lights, and we have never seen any reaction to those.
And can you use the detectors offline and see the results afterwards?
You can wear the dosimeter, for example, and go work in a lab that doesn't have the base installation. The dosimeter would store the last active hour of second-by-second data. And besides that, it would store dose per hour for up to 5 years. So you would be able to work during one day in a different room and then see at least your dose per hour when you connect it.
And then there is a little funny question here. Is it sensitive to drops?
Good one. It actually is a good question. Yes and no. The sensors are a wee bit sensitive to drops because we measure really tiny currents and pulses. And the mechanical impact from a drop would induce tiny currents, which normally would trigger an exposure, a false exposure. But our dosimeter, let me pick it up again. It includes an accelerometer, and we use that to track any mechanical impact. So if it detects an impact, then it will momentarily shut off the measurements for just a second. So you wouldn't get any false data. And you might object that then it doesn't measure. That's correct. But we figured that if you drop it on the floor, then that measurement wouldn't be super accurate anyway. So we decided that that's a good compromise.
Is there any type of alarm if the dose is or the dose rate is too high?
there's not. That's also something we tested a long time ago with some prototype users. And the comments that we got back then was that it's too disturbing if it sounds or makes sounds, because there's this convention that any alarms within interventional X-ray rooms would normally be related to patient safety. So if this one made a sound, then that would sort of violate that convention and throw people off. There's also no light, and the reason for that is because it's not sterile. So during any procedure, you would wear the lead and then this dosimeter, and then you would have a sterile apron or gown on top of it, so you wouldn't see any lights anyway.
There is someone asking about the scale. It's logarithmic, right?
It is logarithmic, and the first segment, or the first few pixels, symbolize 40 microsieverts per hour, and that's just above the detection limit, which for the dosimeter technically is 25 to 30 microsieverts per hour, depending on beam quality and energy. The scale on the display goes from 40 microsieverts per hour up to 20 millisieverts per hour. And in our prototype testing and experience, we found that to be a workable interval, and which shows to make it logarithmic to, on the one hand, make sure that we fit the higher exposures, but still be able to show something also in the lower range. Otherwise, we either wouldn't be able to fit the higher ones, or the lower ones would just round to zero. The sensors and the dosimeters themselves measure much higher than indicated on the screen. So it's specified up to 150 millisieverts per hour with the best accuracy. And then it's specified to 300, 500 millisieverts per hour and 1 sievert per hour with the reduced accuracy.
So we are running just a few minutes over here,
Okay.
but we do have quite a few questions still pouring in here. So if you'd like to stay, great, and we'll answer a few more questions for you guys.
Perfect.
And it's regarding the memory of the i3 dosimetry. How many data measurements can it save or can it store?
So the system stores dose data in 2 places, basically. And it's the same regardless if you have the i3 standalone or the i3 OSD. Let's start with the dosimeter. It has an internal memory, but due to space and power constraints, it's a bit smaller. So this one can store 3,600 samples of dose per second data. So that could be 1 hour of continuous exposure, or it could be 10 minutes today, 10 minutes yesterday, and so on, up to 3,600 samples. When you exceed that, it starts overriding the oldest data. In addition, it also stores dose per hour, and it has space for dose per hour measurements for continuous use up to 5 years. So 2 memories there: dose per second, 3,600 samples, and dose per hour up to 5 years. The hub or the display store the same things. It makes the same distinction, but it has space for all the dose per second measurements up to more than 10 years for dose per second and dose per hour. And it also gives you various ways to compound that into dose per day, etc.
Is there any limits regarding how many PC and softwares that can be used?
So we have a few different software packages and interfaces. Dose Viewer is a free and included software. You can install that on as many PCs as you'd like. If you lose your hard copy, you can also download it for free on our website, RaySafe.com. Same thing with the web interface on the OSD. As long as you're on the hospital network, any computer which is on the same network can access the web interface. It can be password protected, but you would still be able to reach the interface. The Dose Manager software is an optional software, and it's a license per installation. So one license is for one computer.
What happens if there is power shortage or a power cut of the display? Is the measurement lost or?
No, the measurements are still stored. Same thing for both units. So the measurements are, or the measurement data is non-volatile. If you have a power shortage or a power outage, it would of course turn off, and then it would automatically turn back on when you get power.
And is it possible to see the dose or the data remotely from outside the hospital network?
No, unless you willingly open up your firewall in the hospital, etc. But it's not a function that we offer or support.
All right, everybody, thanks for staying a few minutes over our half-an-hour period here. You will be, once you click exit of this webinar and we close it out here, you will be asked a few short questions. Please fill in the survey for us. And if you have any questions at all, just hit reply to your registration information and you'll get my inbox. We really appreciate everyone joining us here today, and hopefully we answered all of your questions and showed you exactly how our i3 personal dosimetry system works. And thanks again for joining us.
Thank you. Thank you so much.